Hello, this video will go over the elimination-addition reaction mechanism. As stated previously, in order to drive a substitution reaction on a benzene ring forcefully without an electron withdrawing group and without high temperature, we need to use a strong reagent like NaNH2. However, the NaNH2 reaction with this benzene ring and the bromine does not proceed through the regular aromatic nucleophilic substitution where we have a Mesenheimer complex. It proceeds through something called elimination-addition. In addition to NaNH2 being a very strong nucleophile, it's also a very strong base. So, NH2- tends to deprotonate a vinylic proton, and it adds it to the carbon just like so we can form this intermediate. Now, this charge is added to form another pi bond, and bromine leaves, and we're left with this intermediate, a benzyne. Now, NH2- is strong enough to attack the benzyne either at this position or at this position. Let's call them position 1 and position 2. Should the benzyne attack at position 1, this reaction would be a substitution reaction directly on the same carbon that bromine left from. Should it attack on position 2, it would be a different reaction. That's an addition, not a substitution. And the products we get from this are 50-50. So we get 50% 1 and 50% 2. So, to recap, when we form our benzyne that's unsubstituted completely, NH2 can attack at position 1 or position 2, both being 50% product formation. The reaction is as follows. So starting with our benzyne intermediate, NH2- could choose to attack position 2, and the pi bond breaks and goes to position 1. Excuse me. Just like that. And this is where our protonation step comes handy, because we're able to protonate the carbon just like that and form our product. If it went the other way, it would be the exact same reaction, just on the other carbon. So this is position 2, this is position 1. We have our benzyne. NH2- could choose to attack position 1, and the pi bond breaks, and the electrons go to position 2, or to carbon 2 in this case. We have a negative charge here, a pi bond, NH2, and the rest of the ring. Finally, our protonation step, whereby the aromaticity of the ring, or the ring is re-aromatized, because in this intermediate, the ring is anti-aromatic, according to Huckel's rule, because we have an even number of pi electron pairs. This is the elimination-addition reaction.